of an engineer. But what makes engineers role so crucial, you may ask? The answer is pretty straightforward. Ladies and gentlemen, when it comes to engineering, it involves a constant pursuit of new knowledge and innovation. Those are the key driving forces behind the development and the growth. In essence, engineers serve as the steering wheel of this perpetual state of change in the world.
Buddies from the industry, beloved staff members, and my dear brothers and sisters, we warmly welcome you to the Professor E.O.E. Pereira Theatre of Faculty of Engineering, University of Peradeniya, on this wonderful morning of 12th May 2023. We have gathered here today to embark on a prestigious and a unique moment in the journey of development within the chemical and process engineering industry of Sri Lanka. Our aim is to showcase the remarkable talents, skills, and abilities of both the fresh graduates and current undergraduates of the Department of Chemical Engineering of University of Peradeniya.
Indeed, Varshan. So, ladies and gentlemen, today you will have the opportunity to witness the exceptional quality and relevance of the research that our students have diligently worked on, putting their hearts and their souls into their studies. This event is the celebration of their journey and their innovations. Ladies and gentlemen, this is
Voyage 2023. To commence the event, in accordance with the Sri Lankan customs, we will now proceed with the lighting of the ceremonial oil lamp. It is our sincere honor to invite the following esteemed guest to join us in the sacred ceremony.
Ladies and gentlemen, we would like to invite Dr. Udaya Disanayaka, the Dean of Faculty of Engineering, University of Peradeniya, Professor Parakram Karunaratna, Head of the Department of Chemical and Process Engineering, Dr. Nadesh Adasuriya, the Chair of Voyage 2023 Symposium.
Also, we would like to invite one of our staff members representing the Department of Chemical Process Engineering. Also, Mr. Malshan Piyum, President of the Society of Chemical and Process Engineering Students. Mr. Roshan Tarindu, the Student Coordinator of Voyage 2023. Also, we would like to invite 3 students representing E17, E18, and E19 badges to light the ceremonial oil lamp. We would like to cordially invite our audience to rise for this momentous occasion.
We also would like to invite the representative that we have here with us today, representing the NCAP Private Limited, to light the ceremonial oil lamp. Thank you very much, ladies and gentlemen, for your presence. So, as previously mentioned, Voyage 2023 is a pivotal event that showcases the exceptional skills and abilities of upcoming professionals from the Department of Chemical and Process Engineering in University of Peradeniya. It goes without saying that organizing such a grand event requires immense effort and dedication as it holds a tremendous importance.
Yes, of course, Sandhu. As a society of chemical and process engineering, we have received invaluable guidance from our mentors from the very beginning of this endeavor. Today, we are fortunate to have one of our esteemed members, Dr. Nadeesh Adas Surya, serving as the chair of Voyage 2023. I am certain that he has valuable insights and thoughts to share with us all. And it is my pleasure to invite him to address the gathering and to welcome you all. Sir, the floor is yours.
Good morning, everyone. Dr. Udaya Disanayake, Dean, Faculty of Engineering, University of Peradeniya, and Professor Parakrama Karunaratne, Head of the Department of Chemical and Process Engineering, University of Peradeniya, and Professor Nilwala Kottegoda and Dr. Jerome Ramirez, our keynote speakers today, who are joining remotely via Zoom platform, and members of the academic staff and administrative staff, guests who are joining from the industry, and dear students and ladies and gentlemen. It is indeed my great pleasure for me to welcome you all to this very special occasion, Voyage 2023 Undergraduate Research Symposium of Department of Chemical and Process Engineering, University of Peradeniya, organized by the Society of Chemical and Process Engineering students for the second consecutive time. Dr. Udaya Disanayake, the Dean, Faculty of Engineering, University of Peradeniya, sir, I warmly welcome you to the Voyage 2023, and we look forward to hearing your vision and guidance towards the research and development activities at the faculty. Next, I welcome Professor Parakrama Karunaratne, Head of the Department of Chemical and Process Engineering, University of Peradeniya. While appreciating your continuous guidance and support you have been offered on us throughout. Next, I would like to welcome our keynote speakers for today. We have two keynote speakers for today's event. Professor Nilwala Kottegoda, a distinguished professor in chemistry attached to University of Sri Jawaharlal, and currently she's at Rice University, Houston, as an academic visitor. I warmly welcome you, madam, and we are so pleased to have you with us today. Our next keynote speaker, Dr. Jerome Ramirez, joining us from Queensland University of Technology, Australia. And thank you again for accepting our invitation to grace this very important event. Also, I will welcome all the academic members of the department and from the faculty as well, and the guests who are from industries who join with us today physically and remotely to be a part of this event. At last, but not least, dear students, my sincere congratulations to all the students who will be presenting their findings today at Voyage 2023. As in previous research symposiums, Voyage 2023 will undoubtedly become an excellent forum for sharing knowledge in latest developments in the field of chemical and process engineering related disciplines and future trends in many industries. Also, this will allow us to broaden our horizon by developing important networks and engaging in fruitful collaborations. I'm extremely happy that you have joined with us today to witness the success of our students. Thank you very much.
Thank you very much for those inspiring words, sir. So with that, ladies and gentlemen, we will be moving ahead with the event. So when it comes to the name of this symposium, Voyage. The word voyage means a journey which involves either sea or the space. Indeed, when it comes to the sea of mass knowledge out there, the Department of Chemical and Process Engineering is the unsinkable ship which brings us, the students, in this beautiful voyage. So, ladies and gentlemen, this is the time which the captain of this ship addresses you all. So, it is with great pleasure and honor, I now invite Professor Parakram Karunaratna, the head of the Department of Chemical and Process Engineering, to address the gathering. Sir, please enlighten us with your words.
Good morning, the Dean, Faculty of Engineering, Dr. Udaya Disanayaka, and also Dr. Premila Gamage, representing the heads of the department of other department in the faculty, dear staff members, and then also I would like to remind our two keynote speakers. Thank you very much actually accepting our invitation to act as keynote speakers, and then also dear student, staff members. So this is actually one of the annual event in our department. It's a kind of culmination of our student effort. Because in engineering, if you take research, is a one important aspect. It's an integrated part of engineering because even for a simple thing like ordering a part of an equipment, spare part, you need to do some research. But all the way to develop new products, new processes, and also to address maybe environmental challenges that we are facing as chemical and process engineers. And then also the other issues like energy crisis, food security, energy security. To address all those things, actually, we need new thinking, new knowledge. So our knowledge is limited what we can give here, but actually when you go out, you should be able to grasp new knowledge and then apply them accordingly. So this is actually the purpose of our inclusion of this course. So we have about 3 modules covering the research component. So basically we want our student to train well in research, and especially those who go out for postgraduate studies. Actually, this is the strength that you have, because you will be well trained. And we have witnessed that one because for our postgraduate student or our graduates, there is a big demand. We haven't found any difficulty in finding places for our graduates, especially with at least second class honors, first class honors. They will easily find places and so on. So this is actually the strength that we have. And then also I would like to thank the organizing committee, especially Dr. Nadish, actually, even though we have a very busy schedule, and also he's engaged in many other activities, organizing the first year welcome event, and also the ongoing orientation program, and also doing some research coordination with all those things. I appreciate your dedication for this work and then bringing this one to this level. And not only that, actually, we are facing very difficult time as department. Despite that, members actually people who guided our students to this level, and then complete this research at a very high level of quality. We have difficulties in finding funds. We have difficulties in finding even some chemicals and so on. But despite all these things, actually, with the support of you only, these students could do this one. And also, I think this is a very good opportunity for all students, including the present student, to see actually what you can do with your dedication and the commitment. So I hope everyone will take the message. Okay, we have difficulties, but if we work together and also with some courage, I think we can overcome these difficulties. So I congratulate all these students who are actually present in their research findings today. So it's basically individual research that we do at the department. So it's a load actually for us as staff members, but we want students to learn independently because otherwise probably there will be some free riders and so on. We want to avoid that one. So at the end, basically, you will learn, actually, you will understand the importance of actually the self-learning, ability to gather information from authentic sources and then collate them to generate new knowledge, understand the present status of a problem or a matter, and then also going forward beyond that. So without taking much time, I congratulate again for all those students or graduates presenting their research finding today. And I wish you a very fruitful day ahead. Thank you very much.
Thank you very much, sir, for your wonderful insights and your thoughts. We are grateful for the leadership and guidance you have given us throughout. Next up, I would like to invite another special guest to address the gathering, that is none other than the Dean of Faculty of Engineering, University of Peradeniya, Dr. Uday Disanayaka. Dear sir, the stage is over to you.
Very good morning to all of you. First of all, thank you very much for inviting me for the research symposium of the Department of Chemical and Process Engineering. Head of the department, Professor Parakram Karunaratne, and head of the organizing committee, Dr. Nadesh Adasurya, and all other staff members from the department and also from the other departments, and two keynote speakers, Professor Nilbala Kottegoda and Professor Jerome Ramirez, and dear students who are presently doing the undergraduate program, and also the students who have completed the work recently. I think head of the department very correctly emphasized the need of doing research work seriously during the undergraduate period, according to the guidelines or the given in the ISL accreditation manual. Our aim is to produce graduate engineers who can solve complicated problems. So that means when you go out and start practicing as engineers, maybe not every day, but at a time, you are supposed to solve a problem which you have not come across before. So in order to face that challenge, doing research is very, very important. And I am very glad to report that about maybe less than 2 weeks back, one of our staff members, Dr. Dhammika Alkadua, has received a very, very prestigious world award for the research work he has done sometimes back during his postgraduate research period. So the award is called 2022 ACM Software System Award, which was awarded for the development of groundbreaking high-performance operating system. I think most of the staff members are aware about that. I'm sure you are also aware about that to some extent. Dr. Dhammika Alkadua, together with 13 other researchers, he has invented, I think according to the information I have received, it is something like a World Wide Web. You know, I think it's a very, very potential achievement. And I think maybe at the moment we can't see the, I mean, it looks like it is my background is structural engineering, so I am not in a position to explain it very deeply because it is software engineering, but it looks like something a very, very promising and very, very innovative work. And so the influence of that will be transferred to the general public, I think, in the near future. So this according to the information I have received, this award was received, I think it has been given for the last 50 years, but Dr. Al-Kadwa seems to be the second Asian person who has received that award. So while congratulating Dr. Dhammika Al-Kadwa, the point I want to emphasize is that the importance of the research, right? So maybe what you are doing at the moment, because he has done this work about maybe 15 years back, but I think before he left USA for undertake this work, he told that he want to further, his aim is to further develop what he has initiated during his PhD research work. So I think within a period of 3 months, I think that they have worked on that, and then there's a result from that. So similarity for the work you have done today, maybe you have, I don't know how deeply you take it, but I think the point is for you to take it very seriously and do it to the fullest extent with the help of very, very supportive and knowledgeable staff members available in your department. And one day that may go into a destination which you will never expect during your undergraduate period. And also, I think we know that all of us are in a very difficult economic and social condition at the country, and this type of innovative work, and then innovative work related to new material and new processes is very important to give a boost to our economy. And therefore, I think I sincerely hope that some of this your work will not stop at this research publication level, but it will go to the product and process level, and it will be helpful for the development of the country. And then before I winding up, I would like to congratulate to the organizing team, because as the Dean Engineering, I know how difficult these days to organize even a very simple activity, but within a very short period of time, Dr. Ada Surya, with the help of the other committee members of this society, they have organized a wonderful event, and I think I certainly wish that this will be a very productive day, and you will be able to get the very good outcome from this work. So finally, I would like to emphasize that the research, I mean, we used to have research sessions for the faculty sometimes back, but now we are since there is a university level research symposium, that IPERS, we are no longer conducting it at the I think during the last years we did not conduct it at the faculty level, but I still think that maybe because of the logistic difficulties, but I think that it is very important that we carry out multidisciplinary type of research. I think chemical and processing engineering research work is, I think, by nature, it is multidisciplinary, right? So I think because that University of Peradeniya is one of the very few places where we have 9 faculties together, and it is very good if you can extend your research work with the I mean, possible maybe medical faculty or even arts faculty, agriculture faculties, if you can get together with the staff members from those faculties, and if you can develop multidisciplinary research, I think that is going to be very useful in terms of the final results, and also to attract funding, because the funding agencies would also like to fund if the research activity is multidisciplinary. So with that remarks, I would like to conclude again by wishing you a very good day, and thank you very much again for inviting me to tell few words to all of you. Thank you.
Thank you very much, sir, for your presence at our event and for all the kind and appreciative words. We are honored to have it have you here today with us. So, ladies and gentlemen, moving on with our agenda, it is said that it's better to one day with a great teacher than 1,000 days of diligent work. Well, in today's agenda, we have not just one, but two great teachers, great keynote speakers presenting their keynote speeches to you. Now the time has come for the first keynote speech of the day. To introduce our keynote speaker, I would like to cordially invite Dr. Anushka Ilangasinghe, a beloved senior lecturer of the Department of Chemical and Process Engineering. Madam, the stage is yours.
Thank you, Sandun. Ladies and gentlemen, it is my honor to introduce Professor Nilwala Kottegoda, a distinguished professor of chemistry at the University of Sri Jayawardhanapura. Professor Kottegoda obtained her BSc in chemistry from the University of Peradeniya and PhD in material chemistry from the University of Cambridge, UK. Her research interests are centered on nanotechnology applications for various fields such as agriculture, water purification, desalination, and drug encapsulation, and many more. Her research has resulted in numerous publications and recognition, including being selected among the most inventive women scientists in the world by the World Intellectual Property Organization. She was also a Fulbright Fellow at Rice University in Houston, USA in 2018, and has received several awards, including the Presidential Research Awards, National Science and Technology Awards, National Research Council Merit Awards, and Third World Academy of Science Young Scientist Award to Sri Lanka in 2013. Currently, she is an academic scholar at Rice University of Houston, USA. Her contributions to science and technology has been recognized both internationally and nationally. And we are honored to have her here with us today. Thank you very much.
Good morning, ladies and gentlemen. I hope you can hear me. Are you audible? Hello. Good morning, and I'm truly honored to be the keynote speaker for this gathering today, especially to enlighten the young inventors who wish to take part in the next generation of innovations of the country. And also, I'm really happy to be here because University of Peradeniya is my own alma mater. So, and thank you very much, Dr. Nadish, for inviting me for this session. And I really was wondering what to share with you. So I felt it's good to share some of my experience as a researcher working in Sri Lanka and trying to make an economic impact to the country during the last 15 years. So I thought I will share some of my experience in order to give you some lessons learned during my journey, which will enable you to initiate your journey. And so with that little note, Let's see. We can see today the world is moving towards different technologies. You can see the rapid change in the landscape of technology in the world. So these are some potential economically disruptive technologies by 2025. You can see what is in the list, what is in the shelf. So these are the areas that you need to think about. So as chemical engineers, when you plan your journey today, now you have initiated your journey, now you have to think of where you are going to be in another 5 years, because that would be the time that you will be contributing, economically contributing to your country. So you have to be relevant. So these are some technologies that will support you, or that will help you to plan your journey at this stage. You can see mobile internet, automation, Internet of Things, advanced materials, 3D printing, energy storage. So very close to your hearts as chemical and process engineers. But keep in mind, 65% of the children entering primary school today, or even you entering the university or starting your journey at the university, would not know what jobs will be available to you in the future. So it is very diverse. You can't predict about the future. You can see self-driving cars, wearable medical devices, 3D printing, where people are working on in the future, you will see a lot of bioprinting happening, and there will be many miniaturized factories where human duties will be taken over by machines. So where are you going to fit as chemical engineers when it comes to your time, your turn? So this is the question that you have to ask today. Okay, am I relevant? So it's very important to be relevant. Otherwise, you will end up with no work. We can see many professions are not relevant in the next few years. So, we Sri Lankans, we have a proud history. We talk about our proud capabilities, science, technology, and engineering. We were no second to any other nation in the world. Are you aware that the first wind-powered iron smelting technology was invented in Sri Lanka? Or we were called granary of the ancient East because of our agriculture technology. We were the first nation in the world to have a hospital system or irrigation systems. And also we were trading spices. We were trading gems from Sri Lanka. And also we are talking highly about nanotechnology, biotechnology, and many other new technologies. But in our past, we can find evidence where our ancestors have used these technologies. A good example is Damascus steel. These swords made of Damascus steel was first made in Sri Lanka and India. So we had wonderful technologies. But students, where are we today? What happened to this proud nation? Where did we go wrong? Did you ever think about it? Something somewhere is wrong. we are on the voyage of a collapse. Our present economy is really, really collapsing. You can see, if you look at the economic activities happening in the country, based on our GDP, manufacturing accounts for only 15.6. Construction, 6.9. You can see total of only 26.4 is contributing towards the GDP by industries. Also, did you know that we are the highest cost to obtain a liter of purified water in the world, or highest per capita expenditure on food? From a salary of an average person, 57% is on food. We are the only nation in the world. And 50% of our agriculture production is lost as post-harvest loss. Did anyone think about this? And we are exporting raw materials, agro-based product for a very low price. We never make the profit out of our available resources. So today, Sri Lanka has become a hub for consuming goods rather than manufacturing. Unless we change this economic ecosystem as a nation, we will never be able to come out of this black hole of economic crisis. We will be talking about it over and over. In my life, in my career at least, I have witnessed we talking about all these topics for the last 15 years, but still we are at the same level, not even a minute change in our thinking pattern. You can see this picture. You can see the top picture is the graphite industry in 1910. And the bottom picture is after 100 years, 2010. There isn't much change. In another 100 years, our next generation will have the same picture in their presentations if we keep on continuing with the current commodity track. We are in a commodity track where we do not do any value addition to available materials. You can see, if you look at the landscape of Sri Lanka, these are some resources that we are not taking the maximum, or we do not utilize them to the maximum. You can see the list. I can give you a long list of things available to us. So students, we have enough resources available. It's the attitude, it's the approach, it's the working, we all need to get together, work together. Scientists need to work together to make this happen. Otherwise, we will be only talking about this topic. If you look at, as I said, graphite is one of the most important material or most precious material available to Sri Lankans. You know, we sell graphite at 1 metric tons at 1,700 USD. The value-added product. So graphite itself has some applications, but to make the real advantage of this material, we need some kind of, or we need to think about the value addition. You know, from graphite, the most important value addition would be the spherical graphite. So these are some applications of raw graphite, which we have in the country, but it is not the actual income generator. Spherical graphite, if you look at spherical graphite, with the lithium-ion battery market taking over for the at least next 2 to 3 decades, graphite anode will not be replaced by any other materials. So we have a huge opportunity in developing spherical graphite. It's not a big, it's not a very difficult value addition. I'm not talking about the very high-end value addition. This is a one step further, spherical graphite. The value is USD 2,500 at the current rate per metric ton. If we don't look at least this kind of value addition, where are we going to end up? Because today, the graphite market is captured by China. Do you know the purity of the graphite available in China versus Sri Lanka? Our graphite is 99.999 pure graphite. But Chinese graphite is below 20% pure. But what do? They take the 20% pure graphite and they purify it and make spherical graphite. And they have captured the highest share in the world market. We are not thinking at least of our own graphite. So if the most important value addition would be the graphene, because graphene would be the next generation or 21st century wonder material. So it's currently 67,000 to 200,000 USD per metric ton. So forget about graphene. Think about spherical graphite. Because in the future, if you don't do it today, you will have no opportunity in the future because all these minerals are now being chemically synthesized. So there is no point of keeping this for next generation. Yes, you have to preserve it for next generation while using it for this generation value creation too. So this is a very simple example to share the current situation in the country and to show you the available opportunities. Now we all are, I'm sure you are familiar with these two words, from resource-based economy to knowledge-based economy. So at least in my life, from the day one I entered to my career, I have been listening to these two words. Every day we say that we are moving towards a knowledge-based economy, but yet that day did not arrive. I'm still waiting for knowledge-based economy to arrive. So our research, I'm a material scientist, and my research initiated at Peradeniya University, then to Jayawardhanapura University, and then Sri Lanka Institute of Nanotechnology. These are the three institutes where I started my career. So when I started my career with my team, I think my first team member in my research team, I'm very proud about him, Dr. Nadish Surya. He was my first researcher working with me, and I can see how he has achieved his goals. So we had a simple motto for our research group. That is, we use very fundamental science. So whatever we do is scientifically validated. And we look for very simple solutions. We do not look for very complicated chemistry, very complicated engineering, because those cannot be implemented under our ecosystem. So we never talked about developing a drug molecule, but we were talking about a simple solution to an existing problem. And also very important as engineers, you have to think about this sustainability. Now we are talking about circular economy, green economy, and carbon footprint, energy footprint, water footprint. So all this should be taken into your equation when you plan your research. And very importantly, as engineers, you will agree with me, research has to be scalable. Otherwise, lab level research will not bring any impact on our economy. So based on these 4 words, we initiated our work, and we were always following the toolbox gifted by the nature. So if you look at the nature, for most of our problems, we are able to find solutions. So most of our work is based on the nature's toolbox. And also, we were always looking at global issues. Therefore, our research has been like starting from basic research, then to applied research, innovation, protection of our inventions, because it's very important. We don't talk much about the protection of our patents or IP rights. So that is also important to be considered in your research cycle, and the wealth creation. So this is the cycle that we focus on. And also we focus on UN sustainable goals, because we don't want to be irrelevant in another 5-10 years. These are the global issues that we currently try to tackle, that is zero hunger, good health and well-being, clean water and sanitation, industry innovation and infrastructure. So this is basically the glimpse of our research. Now, I will share a few of our findings with you, because this project, as I said, Dr. Nadish and Dr. Imarka both are back after their PhDs. They were the basic, the green hands who created this project happen. So we had to develop a slow release fertilizer back in 2010, I guess, in order to solve the global nitrogen issue. So if you look at the global nitrogen issue, you know, for plants to grow or to get a good yield, plants need fertilizer. Out of the fertilizer we apply, especially nitrogen fertilizer, is very inefficient. 70% of this fertilizer is washed off as greenhouse gas emissions, and some of them get into the water table. Therefore, plants absorb only 30%. If you look at the economics, so economics is very important. As chemical engineers, as scientists, we should have an understanding about the economics. Otherwise, no point of our findings. If you look at Sri Lanka imports, this is the economics that existed when we started this project. This is where we started. This is how we thought that this project can make an economic impact. Sri Lanka imported 368,000 metric tons of urea. So if you look at the loss and the benefit to the plant, we are just wasting $308 million a year. Just imagine if you save 10% of the money that we use for urea, it will bring some economic benefit to the country, because we have to bring urea from outside. So we had to find a solution to this problem. And as scientists, you may agree, we have to start by looking at what is available, literature search. So we did the same. We looked at the patent literature very importantly to see whether we can come up with a new idea, because innovations are very important. When you look at the patent literature, we found out that there were only 400 patents based on agriculture, nanotechnology innovations. So we had a good stage to play. We had enough opportunities. There was plenty of room in the area. So with that, our team together, we came up with an idea how to minimize the wash off of this urea. You will see how simple is the idea. Here we looked at the nature. As I said, nature is the best scientist. If you look at the nature, we know our bones or any animal bone is made of a phosphorus nanoparticle, that is hydroxy nanoparticle, combined with collagen protein. It's an amide. Protein is amide and hydroxyapatite nanoparticle. So, in the agriculture, we use hydroxyapatite as a phosphorus source, but it is not nano. So we thought, why not make a hydroxyapatite nanoparticle where when it is nano, as you may know by now, it has a very high surface area to volume ratio. And we thought that the existing nitrogen source is urea. It's not rocket chemistry, rocket science. We took urea. It is an amide. It is the simplest amide, like the collagen protein in our bone. Because these two combine well. That's why our bone is very strong. We thought if we combine hydroxyapatite nanoparticle with urea, we should get a slow release fertilizer where urea will not wash off easily. In other words, now urea is bound to a second matrix. It cannot come out easily. So this was the simple idea. We took two things and our high school chemistry. This is high school chemistry. It says urea can make a hydrogen bond with hydroxyapatite. This bond is not as strong as the bond in our bone, but not as weak as a Van der Waals bond. So it was very moderately strong, where we can program the nutrient to be released in a slow manner to the plant. So this was the very simple idea, two things together, mix together and come up with the composite. You can see how simple if you look at the problem in a very simple but in an innovative angle. It's very important to see it in an innovative angle. Very simple beaker chemistry, we did it, and then we tried to analyze it. We was really lucky. I'm still saying the hands of these two scientists were really green. First attempt, we came up with the nanoparticle. It was a very nice nanostructure, and they developed two other new nano systems with the same system. I'm not going to talk about it because this was the simplest approach that we had. Now we did it in the lab and we analyzed. We did all basic scientific study on this material. After conducting, you can see how nice is the structures. You can see the nanoparticles. Really, these were in the nano range. And then next challenge to any scientist. We ignore most of the time because our scientists or we chemists work in silo, and engineers, we do not bring them into the equation. So it was very important for us to take this off the bench. That is your duty, chemical and process engineers. Your support is always needed. Otherwise, you can't make this happen. Because fertilizer making in a beaker will not make any impact. So this is the time we look for support of your expertise, chemical engineers. So they worked with us together. They studied the process, scaled up into a pilot plant, which could produce, today it can produce about 500 kilograms a day. Slimtech is currently producing it at that rate, and soon they will put it in the market, this fertilizer. So they started producing this. So you can see, if your solution is simple but innovative, you can scale up too. Engineers did it, wonderful engineering capacity from our own country. And once you produce mass scale, as scientists, we can't stop there. A publication is not an happy end. Remember, it doesn't bring it, but real value comes when you talk to the hearts of poor. So we did field trial. We did the pot trials, then small scale field trials, then large scale farmer trials. And we found out our the fertilizer produced in our lab was able to reduce the fertilizer usage by 50% while increasing the yields by 15% for rice and 10% for tea. So for both of these crops, we have conducted the field trials. So although I'm talking about it in few minutes, these took efforts of several years. This is several years of effort, 24/7 in the lab. Young scientists working very hard to make this happen. And then with this, we knew that the fertilizer is working very well. And we were able to come up with, up to date, we have 4 US patents, 1 PCT, 3 national patents, 1 Chinese and 1 Philippine. So this is very important, securing your IP rights. So this was the first patent in nanotechnology obtained by Sri Lanka in the US. So we were able to get this patent within 18 months of our work. However, patent was not an happy end again, because this patent didn't take us anywhere. It was just sitting aside. Nobody cared it. Some people said your work does not value at least the A4 sheets that this patent has been written. So that was the comments that we received from our own scientists in Sri Lanka. But our team didn't get demotivated. What we did was we published. Sometimes publications have a big impact. This is one example where a publication made a significant change or significant milestone in our journeys. This publication in Current Science. So we were able to get this publication after, Nadish may remember, we had about 12 rejections. Starting from Nature, we submitted to all possible journals, but everybody rejected us because we are from Sri Lanka. But this Current Science, low impact journal, made a big difference, because this journal article was picked up by a giant fertilizer manufacturer in India, Nagarjuna. So as a result, they wanted our technology, they wanted to acquire our technology at this point. So although we could not complete this technology transfer entire process, the initial work done with Nagarjuna gave Slimtech a lot of initial capital to run the institute. So that was a good beginning for Slimtech, good beginning for Sri Lankan scientists to understand how commercialization, or how to take a product from bench to market. So this process, the journey was really, really hard journey, because we had to work really hard to get to this stage. So you can see how difficult, how hard we have to work if you are to make an impact into the economy. So this is one example, one success story, I would say. I proudly share this with the young scientists like you, because this gives you a lot of messages or a lot of examples or a lot of lessons for you to take your journey to the next stage. Then we also looked at epavala rock phosphate. As I said, we use the hydroxyapatite nanoparticles in our innovation as the next generation fertilizer. We developed the same composition using epavala rock phosphate because it's just staying in epavala. We don't take a significant advantage out of this deposit. We have a very good rock phosphate deposit which has a longevity of 200 years. All world rock phosphate reserves will be depleted in another 150 years. But we have a good deposit in Sri Lanka. Then I have already talked to you about graphite, but Pulmude beach sand. Again, a pathetic situation where we export our beach sand as a raw material at a very low cost. I will talk about it in a minute. So our next attempt was to see how this titanium can be value added. If you go to Pulmude area, the eastern coast has a very special black sand, rich in titanium dioxide. This is the 9th best titanium reserve in the world. It has about 60% titanium dioxide. So one of the best reserves in the world. But do you know our current export price is 1 metric ton at $150 USD 150. Then titanium dioxide. If you value it to a titanium dioxide, you can earn 1,400 USD. But if you go up in the ladder, ferrotitanium alloys, you can see there are a lot of applications in titanium alloys, and then titanium sponge, where titanium is one of the most precious metals in the world, where it is used in bone implants in medical industry and making aeroplane parts and space equipment. So this is a very precious metal. World has only 3 methods developed so far to convert beach sand into titanium metal. But our Sri Lankan scientists, we were able to value add to our own titanium dioxide available in Pulmude. Not to get the titanium dioxide, of course, we produced titanium dioxide, but we went another step further where we were able to make titanium metal. You can see it was one of the most difficult parts, or one of the most difficult. Our scientists, Sri Lankan scientists, were able to come up with a new method. Globally, there are only 3 methods. We have the 4th method patented in Swintech. So this you can see from the titanium source, we used a very special chamber, very special method to convert to titanium metal. And this method was scaled up. Again, you can see where you come in the equation. So this method was scaled up to a small reactor where we get titanium metal. Further, we use this titanium beach sand in order to get few more value-added products. Especially, we tried to address one another global issue, that is post-harvest production loss. As I said, 50% of our agriculture production is lost. So here we developed a coating. It's like if you take things like fruits and vegetables like bananas and other vegetables, you know, they easily go bad very quickly. So what we did, we used pulmude beach sand, and without doing lot of processing, without going through a complicated processing pathway, we took out the iron titanate part in this sand. Just a simple separation. And then we converted it into a coating, which could be used in various fruits and vegetables. And we found this coating is visible light active. You know, titanium dioxide, if you take, it's only active under UV light. But our pulmude sand, or the full sand in pulmude, has already iron doped titanium dioxide, which is active under visible light. So no, this was there, nobody thought about it. So we have a patented process to make food coatings from this pulmude beach sand. So we were able to increase the shelf life of fruits and vegetables by 100% by using this coating. It's a very thin coating, very harmless. It's not bad for health or anything. It doesn't change any taste parameters, any nutrient parameters in the food item. So this is one example where we did the value addition to our own minerals. I think you can see what are the available methods, available resources for us to do wonders. You can do a lot of things. Then Sri Lanka has iron-bearing minerals. So we were able to again value add and make nano iron oxide from these Sri Lankan ores. And these iron oxides can be used in various industries. One is the glove industry. You must be wondering why we need iron oxide in glove. In glove industry, there is a major issue. In particularly, when you use or when you wear gloves in food and pharma, you know, packaging, food and pharma packaging, the production team wear gloves, latex gloves. And these small pieces of gloves can get into food item or your pharmaceutical manufacturing items. Then what will happen? All these gets rejected because it's not good to have glove pieces with your food or your medicine. So that was a major issue in the food and pharmaceutical industry. Here we developed a glove which has magnetic properties. Therefore, if there is a little piece coming out of your glove, this little piece will be detected at the metal detector point, because you know, after packaging, all these items will go through a metal detector. So at that point, you can see if there is a glove piece inside your food or your drug packaging. So this was one application that we proved with our magnetite ores. And this is another project that we have been doing with University of Peradeniya for 10 years. So we have been trying to develop a multi-purpose water filter. So our group at Jayawardhanapura, University of Jayawardhanapura, together with Peradeniya University, we developed a very special nanocarbon. We developed a method to functionalize nanocarbon And this method or this functionalization removes the water hardness, fluoride, heavy metals, and microorganisms. So this is a multi-purpose filter developed by our team. And I'm very proud to say this process has been scaled up now with the private partner. And our chemical engineering expertise was given by one of your faculty members. So Professor Kalpage is the engineer in charge of this process. He gave us the expertise together with the National Research Council funding with the private partner. So we were able to scale up the process. Now we are doing the parameter optimization of the pilot plant. So you can see you have a lot of opportunities if you look at it in a different way. Get out of your boxes. Now it's time to think differently. Unless you think differently, you can't do a different, you can't make a difference or make an impact to the current landscape of scientific innovation. So these are few work that were done by my team. And in Sri Lanka, the biggest bottleneck, biggest problem in scaling up any industrial process is the unavailability of chemical industries. So, dear students, as chemical engineers, please think about this. Sri Lanka had sulfuric production facility. Sri Lanka had sodium hydroxide production facility. All shut down. Now nothing is operational. Without having these basic chemicals, there is no point us talking about scaling up, value addition. Nothing is going to be economically impactful unless we have our own chemicals produced within the country. So that is where the bottleneck, that is one major hurdle that you have to jump. All these industries were there. If you look at it, this is the potential industries, or these are the industries that can be established in Sri Lanka. You know, Sapagaskanda refinery, if you expand it, you can produce ammonia, you can produce nitrogen fertilizers. About 3 decades back, we produced fertilizer in Sri Lanka, you know, due to a failure in a pressure gauge. This fertilizer plant was completely dismantled and sold for scrap iron to a Middle East country. The plant is still working in that country. So we just ignore our resources. If we look at Epavala rock phosphate, you can make triple superphosphate. You can make single superphosphate. Thing is, you don't have the basic chemical industry. So it's your turn to think about it. Think about energy efficient ways of doing it. Think about green technology. Think about the circular economy. These are the words that you have to, these are the things you have to focus on. So if you look at the holistic picture of the entire landscape of Sri Lanka, I think you can make a big difference. So this is my dynamic team. I'm always proud to be a member of this team because everything was done by this team members. Some are from Peradeniya, Chandani and Professor Ranja. Professor Ajit, a chemical engineer, and Professor Gihan, rest of the team. They are the, excuse me, they are the people who did the wonders. Let's see whether we can make a difference to the current economic landscape through innovation. I hope your journey will not stop today. Your voyage will continue to make the change. Thank you very much.
Thank you, ma'am. So now it's time to raise your questions.
Professor Nilwala, can you hear?
Hello.
Can you hear? Yeah. Thank
Yes.
Nilwala, Anushka here. Thank you
Yes,
very
Dr.
much for
Anushka, I
your
can hear you.
insightful thoughts, and I'm very sure our students take it very positive and move forward. Thank you so much.
Thank you.
Well, ladies and gentlemen, that was one of the most interesting speeches I have ever witnessed. I hope that it's the same for you as well. As ma'am mentioned, change has an economic value. And there was a good question raised on us. When will we get out of this commodity trap and enter into the market? We are still thinking about our own graphite and so many success stories that ma'am has shared with us. It is said that it's better to have one day with a great teacher than 1,000 days of diligent study. And the keynote speech proved that as well. We would like to extend our heartiest gratitude to Professor Nilwala Kotegoda for the wonderful presentation, and we greatly appreciate the effort you have put towards it despite your busy schedule. In the beginning, we mentioned to you that Voyage 2023 is all about the talents, skills, and abilities of the students of Department of Chemical and Process Engineering. When we mention talents, skills, it's not about just bound to academics. Without further explanation, I would like to invite this next set of people, and I ensure you that you will be amazed how wonderful and diverse the talents of our students are. Enjoy.
Oh, as දෙක දැකලා එවන් මගදී ආදරේ කරා ඉන්නවු ආදරේ සිතුවම් කරා තුන් පහසින් රහසක් ඉවා අම්බරේ බාවලා කිය ආදරේ වෙනස් ආවේ ජීවිතේ කියක් ඉන්නවු ආදරේ සිතුවම් කරා ඇඳුම් පහසින් රහසක් ඉවා හිත හිරිවැටුණා ඇස් දෙක දැකලා එවතරේ සුසුමක තියලා හිත හිරිවැටුණා ඇස් දෙක දැකලා එවන් නදාරේ හුස්මක තියලා Cinema, Maya Vipar, say Avia, Dehane Bini, Adareka, Oya Baba Sonata Situbatila, Oya Getu, Chivitaya, Tuilade. Oya Bamba Sarta Sita Badela, Oya Netata Marketu Nachi Vitoy, Umatila Savima, Smakova, Satpala, Santa Pemaha, Nuragi Pala, Ogin Sinapa. idua. Matutuwe an nelenarume asnamane irayama sitiyenume yahane babasanata sita badila magituna jivita makuinane oya babasanata sita badila magituna Sana sabi man, sumaku pasalan sa depan, sampai pemang anurake palang kitsina. Oya bamba sarata sita bandila oya tata magatuna jivitayo matuilane sarata sita bandila oya tata magatuna jivitayo matuilane sabi man masalah satu palang sampai mau kita it's enough. Thank you.
I think it won't be unfair. Next up, we will be moving on to the second keynote speech of our agenda. To introduce our keynote speaker, I would like to sincerely invite Professor Maheshi Damture Bandara, a beloved professor of our department. Madam, over to you.
Ladies and gentlemen, it is my pleasure to introduce Dr. Jerome Ramirez, a research fellow in bioprocess engineering at the Queensland University of Technology in Australia. Dr. Ramirez earned his BSc degree in chemical engineering from University of the Philippines and PhD in energy and process engineering from the Queensland University of Technology. Currently, he is a research fellow in the Center for Agriculture and the Bioeconomy at the same university. His research focuses on techno-economic modeling of technologies that can enable sustainable production with a particular emphasis on modeling, process integration, and techno-economic analysis. Dr. Ramirez has extensive industry experience in process evaluation and design, process safety, and risk assessment, particularly in the petrochemical and geothermal energy industries in the Philippines. He has also been involved in several bioenergy and sustainable production projects in Australia during his PhD study. We are privileged to have Dr. Ramirez with us today, and we look forward to learning more about his exciting research in the field of sustainable production. Thank you.
Good afternoon, everyone, and thank you for your invitation for me to present today. Right. So again, good afternoon or good morning. And good afternoon from Australia. I'm here to talk about the future prospects of chemical engineering. So I wanted to talk about what the future might look like for someone who is entering the chemical engineering discipline and performing the task of being a chemical engineer in the process industries. But I thought that possibly that topic might be different for each person. So I decided to talk about these future prospects through the lens of my career so far. So when I was studying chemical engineering, there was this quote that said, chemical engineering is now a sunset profession, which means there's not a lot in that time in chemical engineering to be developed. People thought that all the unit operations have been developed, all the industries have been developed and are mature, and so there isn't really any need for chemical engineering. But in the last 15 years of being a chemical engineer, I found this to be untrue. A little bit about me. I'm a chemical engineer from the Philippines. I finished my chemical engineering study, Bachelor of Science in Chemical Engineering in 2008. And at the time, after finishing this degree, I wanted to work in the process industries, particularly in the petroleum industry, petrochemical industry, energy. I want to work on maybe bioprocesses, environmental engineering. And so, because when you graduate and you finish your degree, the world is kind of your oyster, and you can just really work anywhere that you want. And so for me, these were the options that I thought would be interesting to me to work in. But then it's not really just about what we want or what we want for our careers, but also how the industry is during that time. So when I finished that degree in 2008, there's this odd thing about the oil price. I wanted to work in energy, in petroleum and petrochemicals, but that industry is very sensitive also to the oil price trend. So if I look at historical oil price data in the early 2000s, the crude oil price was kind of low. So here, at the start of the 2000s, it was really low and it started ramping up towards the end. But what that meant was if the crude oil price was low, then there's also low oil industry revenue. And so there's low activity in the industry. Industry will tend to spend less and also hire less people, including chemical engineers. And so there's also ripple effects in other industries because oil as a form of energy also impacts almost all industries. In the mid-2000s, crude oil price started increasing. And this is because of many factors, including geopolitical conflict. But that means in the industry that revenue is again increasing. The oil companies started increasing their activity again, such as exploration for new oil reserves, new capital projects, drilling, building upstream and downstream facilities to kind of ramp up that production and make the most out of this high crude oil price. So let's change that. Is that better? Yeah, sorry for that. Well, good. Yeah, so oil companies started spending again. Companies are hiring. And so I was able to get into an energy company. But also because of the high energy costs, there's also a move towards, there's more focus on alternative energy. And so the job that I got in chemical engineering was on alternative energy. Right, so it's one of the key trends, if I look back in the early 2000s, was the start of alternative energy, specifically renewables, ramping up. And this can be shown in this graph on the left. From the early 2000s, we can see that wind, solar, and other renewables, including bioenergy, have started to go up. And now, in current times, we are aware that wind, solar, and other renewables are now important parts of our energy mix. But back then, it was still starting, and we've seen many chemical engineers employed in these fields. So what's our role in renewables? The role of chemical engineers in renewables is to support powering new chemical processes as more of these wind and solar generation facilities come online, we'll see more and more supply of electrical energy. So our energy mix is changing from steam or heat-based generation to more electrical. And so we should be able to adapt to that by coming up with new designs that are needed to properly integrate renewable energy, renewable electricity, and renewable heating into the chemical process plants. So there are main considerations such as new regimes of heat recovery and transfer. There's new process unit process scales. In order to scale up, for example, electrocatalytic or photocatalytic processes, instead of having a big reactor, a big vessel, it's usually repeated units. So therefore, the design and the design of the process plant is changing. It's not just operating one big vessel or one big reactor. It's operating maybe 10 or 20 smaller reactors. And so the perspective is also changing, because now, instead of having lots of downtime when the reactor goes down, there's more flexibility, because if one small unit breaks down, then we can still use the other units. So it's that change of perspective which will have systemic effects in how we model and how we design process plants. We also have to consider operating flexibility, because as we know, the supply of solar and wind is not consistent. During the day, there's more solar power. At night, there's less. And we know that the wind also changes. And so it's also important that when we design process plants that use renewables, we also design energy storage systems that match the energy needs of our process plant. The second part, which I've mentioned in the last slide, is energy storage. And as I mentioned, because we are increasing our reliance on renewable energy, we now require high capacity and low cost energy storage from a household level that's requiring a relatively small amount of energy compared to a process plant. And so the importance of having this reliable energy storage is even more important for a process plant. Our role there is to develop new chemical storage, new energy storage technologies, and enable those to integrate properly with our new chemical process plants. One of the examples of these energy storage that we can really have a hand in developing is chemical storage. For example, we can use excess energy to power an electrolysis plant to produce hydrogen, and then that hydrogen could be stored more stably as ammonia. Or we can also develop new battery systems, like such as better lithium batteries, flow batteries, and so on. And when we're developing these new energy storage systems, there's many different aspects that could be considered, such as size of the battery, cost, capacity, safety or toxicity, and also resource use. And these really are considerations that are not new to the chemical engineering discipline. We already have these considerations in more conventional technologies, but we're using that knowledge, applying those to these new technologies. To continue that story, while I was working in the alternative energy industry, I was also interested in biofuel, mainly from designing a bioethanol plant from agricultural waste as my design project. And at that time, that was really interesting, not just to me, but also potentially to the wider in other areas in the world. There was this interest in developing biofuels at scale. So the demand was there. Vehicles needed to have biofuels. And so there was this large push for making biofuels. So in 2014, I started my PhD in Australia. And by that time, the research has moved from a simple bioethanol production process to the thermochemical conversion of biomass for bioenergy. So the third trend that I wanted to talk about today is bioenergy. But really, bioenergy is old technology. If you've ever used charcoal or wood as heating, that's basically bioenergy. But bioenergy will always be used because it's local. You can get your fuel source locally. It's easy to use. It's easy to implement. You can do that at home. And it's also green, which means it uses CO2 that's already existing in the atmosphere. And in recent times, the key bioenergy innovations are the development of liquid biofuels, which makes bioenergy bioenergy more global, because instead of transporting bulky solid biofuels, if we're able to convert a solid biofuel to liquid, we can transport that in smaller tanks, smaller trucks, and that could be shipped energy. Instead of just burning waste to get rid of it, we can then burn it and then recover the energy and use that. The other innovation is thermochemical conversion, which as opposed to a biochemical conversion, has a lower reaction time, and it can use the whole piece of biomass rather than just a part of it. That way, we increase the yields of our liquid biofuels that we derive from biomass. And then the fourth innovation is biorefining. In the process, produce other products, co-products that have high value, and therefore we increase the material efficiency of the conversion, but also reduce waste, reduce cost, and reduce our emissions. So our role there in bioenergy, of course, there's always going to be solid biofuels. The way we are involved, chemical engineers are involved in solid biomass pellets, are in the design of these pellets, and making sure that we are producing pellets with consistent quality that can be used easily for second generation fuels and or syngas through gasification of biomass. There's also emerging trends in sustainable aviation fuels and sustainable marine fuels. And this has come up because for land transportation, so for them to be converted to electric vehicles. But there's been quite a struggle with aviation and marine in converting those to electrically powered transportation. So biofuels or liquid fuels will still be there, and a way to decarbonize that that industry is really to develop liquid biofuels that, that you can. In thermochemical conversion, it's a very heavily chemical engineering piece of technology. Once you generate your liquid biofuel called bio oil or bio crude, there's options for those to be blended with crude oil or to be used in existing crude oil refineries, so that we still use, we don't waste the capital spent in building the refineries, but we're actually producing more sustainable fuels. The other aspect there is to convert these less than high intelligence through upgrading and catalysis. Biomass to liquid conversion process expanded biochemical here on the right. If you look at the components of biomass, such as starch, be converted into building blocks that are able to be converted to these two, and the potential of bio-based chemicals to flow into chemicals that we use in manufacturing different products. And so we develop, when we develop these processes and these new manufacturing processes that use biochemicals, we open up new value chains for biomass, for agricultural waste, for organic wastes that were not yet there. And so our role there is to develop these new biochemical manufacturing processes. And it's not a simple problem, because when we look at biomass, it's a very complex material. So we need to have processes that handle complexity of these biomass components. We need to develop processes that are selective to produce the product that we want to produce. We want to design processes and process plants that are optimized in terms of energy and material use. We don't want to create new emissions. We don't want to contribute to more emissions. We want to control that. And also, we can also have a biorefinery model, which I've mentioned earlier, where it's just really material optimization, but also increasing revenue and improving the profitability of the process. Third aspect to biomaterials, which is the fifth trend I'm talking about today, are biomaterials. So biomaterials could be biologically derived materials, and could be bio-based polymers, biodegradable polymers, or biopolymers such as proteins and polysaccharides. Or this could be materials with biological purpose, such as tissues, human tissues, hydrogels, and the like. And the role of chemical engineering in biomaterials is in developing the process to make these biomaterials. So that might seem easy. We have these old technology where we use typical chemical engineering process to make biomaterials. One of these is the production of paper. We get a biomass feedstock, we process that feedstock, and then we generate a paper biomaterial that's made of cellulose. Now that the push for biomaterials has been both in policy, in market demand, and consumer demand, there's more and more need to make biomaterials. And we couldn't rely on old biomaterials that we've used, because now we need to make biomaterials that are high strength, low cost, and have functionality. And so as chemical engineers, we're there. We need to develop processes to make these, either by extracting these biopolymers from biomass feedstock, or to convert this biomass feedstock to the monomers, the chemical monomers, or the polymers that will eventually become the biomaterials. Another aspect in chemical engineering for biomaterials is the design of novel bioreactors for structured tissue culture. Unfortunately, when we make tissues, either animal tissue or human tissue, that can be developed or produced in just a continuous stir-type reactor. Needs to, the tissues need to be grown in a controlled reactor so that the structure is formed properly. And that's where the chemical engineering reactor design comes in. So in 2008, I finished my PhD and I started a postdoc on process modeling and techno-economics of process waste, processes that convert waste to high-value products. This research was driven by agricultural industries who want to make the production more sustainable through circular economy concepts. And this was a bit surprising to me, because agricultural industries are kind of more conventional. They think more conventional because they're one of the oldest industries in the world. And so for them to say, we need chemical engineering, we need chemistry, we need biotechnology to help us make our production more sustainable, that's a good multidisciplinary collaboration. And so one of the key trends, if I discuss something today, is really sustainability. And this has been quite popular and also contentious, because people can just say, we want to produce something sustainably, this product is sustainable, this product is not sustainable. But we're there, the role really of chemical engineers is to make sure that we are really achieving true sustainability. And that comes in many different parts, but in chemical engineering, we're quite in the center, because we are affecting how products are being made, how we use resources, how we create emissions and outputs that will eventually make itself in the environment, go into the environment. And so sustainable production, we developed this not only for the feel-good factor, like we're a nice company, we produce sustainable products, but also it makes sense for the business to do, because we control the costs and we manage risks related to resource scarcity. In 2015, there was this controversial or widely talked about paper about the planetary boundaries. And this paper was saying that in some aspects, we are exceeding what's available to us, such as phosphorus and nitrogen, genetic diversity. These aspects are actually what's driving the agricultural industry to think more about sustainability. So when I think about sustainability, it's always thinking about the triple bottom line. Of course, it's hard to do something in chemical engineering, in the process industries, in manufacturing, in production, if we don't think about economics. The investment has to have revenue, it has to be profitable, and that sustains the production. So when we think about economics and chemical engineering, we are production focused. We look at production. We want to optimize the processes that happen inside the process plant. We want to use less resources as we can. If possible, we look at low value feedstocks such as waste, and we want to take advantage of the economies of scale. We also want to increase revenue, we maximize value, we maximize yield. If there's a process where if we add 1 unit operation to increase the purity of something, we do that to maximize the value. And so we're focused on the profit. So we want to maximize the revenue, but reduce the cost. We want to make sure that what we spend in capital is justified, and we pay attention to the cost-benefit ratio. But we also look at environment. We want to manage the impacts that our process has on the environment. We want to minimize emissions by making sure that the processes that are employed are optimized. We want to use less resources. We want to minimize changes. As I mentioned, low value feedstock. Instead of clearing out a forest, we can use biomass that's already available as waste, whether it's municipal solid waste or agricultural waste, food waste, construction and demolition waste. And we want to think about circularity. And I'll talk about circularity a bit later. We want to increase the benefits. So we want to maximize the material efficiency. If there's a waste that we can convert to something that's valuable, we want to do that. We want to remediate and restore. And so that's a little bit about correcting the mistakes of the past. We didn't really know, going to affect the environment in some way, but now we have the chance to correct those, remediate areas where we polluted and restore that to the natural environment. And then we want to have a net positive impact or net positive benefit to the environment. We're not just taking away from the environment, but we're also giving back to it. The third aspect is society. This is quite a little bit removed from the chemical engineering practice, but it's important for us to think about what we do and how that affects society. Of course, it has to be a positive change. What we do, we should also think about societal issues such as equity, poverty, and hunger. We need to think about cultural and social fit, the permit to operate. We need to think about sustainable development, and we need to think about the benefit, which is the net impact to society. So one of the things here is about hunger. So if we use more biomass feedstock to make energy, is that taking away from food? So that has been a debate in the bioenergy industry, but it's also prompted the move to using non-food biomass feedstock. And so these are things that help us look into sustainability as chemical engineers, and that practice has been increasing in the last 20, 30 years. The seventh trend I want to talk about today is circular economy. And the circular economy is based on the 3 principles, and it's driven by design. So it's not just waiting at the end for the waste and then possibly doing that doing something to the waste, trying to save as much as we can. So it's driven by design. You design the product such that you eliminate waste and pollution. You can design a process that enables these products to circulate, for the materials to also circulate at their highest value, if possible, and then also to regenerate nature. In the circular economy, chemical engineers again have an important role. We can redesign our production systems to consider now the residues and wastes as inputs. We have to redesign our production process to allow material recovery. We could develop new materials that can be easily recovered. And we can develop new processes that handle hard to recover materials such as organic wastes. So on the right, I'm showing this circular flow of materials in the livestock industry. So this was a project we did with the livestock industry in Australia, where we looked at these hard to recover materials, wastes, essentially wastes from animals and meat production, and cycle them back to agriculture. After that project, I was interested in synthetic biology, and in the present, I'm currently working on research on the industrial translation of synthetic biology, specifically the modeling of bioprocess and fermentation. And at the same time, I've also been interested in the new methods in process modeling, including machine learning and AI. And coincidentally, these are really current trends in chemical engineering. So synthetic biology, it's the rapid development of functional DNA encoded biological components and systems through the application of engineering principles and genetic technologies. It's going down to the genetic material of organisms and making changes, unnatural synthetic changes, so that they could be more efficient, mean more sustainable production, using less resources, using a smaller footprint, rather than cultivating hectares and hectares of agricultural land that could be that same scale of production could be condensed into an area where you have fermentation tanks generating the same amount of products. So this enables us to develop new capabilities and products that can address global issues in health and medicine, food and agriculture, climate and environment, to say a few. So for example, here, I've shown a picture of different colors of algae, which were developed through synthetic biology. And this way we can produce more sustainable dyes and colors that, that could potentially require, that are less toxic and that require less resources to make. So our role here, and really there's a wide range of areas we can contribute with, but I'll talk about the specific, my specific research interest in synthetic biology, which is developing new precision fermentation processes that use engineered microbes to make products. So something like yeast that we use to convert sugars to beer, sugars to ethanol, could be engineered. The yeast could be engineered so that we use sugars, and that we can produce something like proteins, we can produce lipids, we can produce other sugars, and other organic chemicals that are useful, like pharmaceutical inputs in precision fermentation. And then also important here is the optimization of material and energy use. So the processes can be truly sustainable and cost competitive. Of course, because this is new technology, it will be more expensive than traditional production. But if there's a way to really get down to the detail and optimize these processes, it's possible for it to be cost competitive. And then there's also new processes that need to be developed to consider new biological properties of synthetic organisms. The ninth and last trend I want to talk about is machine learning. Machine learning uses data science principles that can be used to address complexity. Some chemical engineering principles, as you all know, can be explained through simple correlations, simple first principles, and material energy balance, mass and heat transfer. But there's other things that are really complex, that would be difficult to really flesh out in a single equation or single analysis. And so machine learning helps us there, because if it's a complex system, we can use this to simplify that calculation. And so what helps this is that the chemical process plants are digitized, and we are now enabled to collect large data sets, which can now feed into these machine learning algorithms. And so what this can be used for in chemical engineering is to approximate high complexity and nonlinear relationships between input and output variables. There's some examples here, such as the molecular properties from structures, development of closure models for flow dynamics, reconstruction of flow patterns, quantification of uncertainty in physical models, prediction of action outcomes, which I have active research in, building better catalyst models, understanding mechanisms, and in process control, prediction of process response to control actions. And so there was this question, or an ongoing question, about the role of AI. Is AI going to replace chemical engineers in the future? My opinion is that it won't. It's because AI really operates on what data we feed the algorithm, and it's easy for the algorithm to make conclusions based on that data. But as I've said here in the slide, machines are only as smart as we let them be. It still require the chemical engineer still needs to be there to link, different aspects of chemical engineering into a design decision, into a conclusion on feasibility, and so on. As the final message, when I thought of this presentation, I really thought about laying out the trends based on my experience, and it's because the chemical engineering career journey varies from person to person, and we always look into the future because that's providing us with our next job, with what we're working on next. And it's always important to pay attention to trends, what's new, what's emerging. And that's really important because knowledge moves fast. And in the early 2000s, when I was studying chemical engineering, machine learning wasn't a thing. Sustainability was just a buzzword, but now it's really it's what chemical engineering is. And try to do what interests you, and of course, don't be a robot. I know everyone, to be in the chemical engineering program, you're smart and you're not really just taking data and generating information. You're also analyzing and critiquing that information as it comes to you. So thank you everyone for this opportunity. If you have any questions or you want to say something to me, just feel free to contact me through email or even through Twitter. And you can find my research on ResearchGate, LinkedIn, and Google Scholar. Thank you.
Well, ladies and gentlemen, we were fortunate enough to witness not only one, but two outstanding keynote speeches in today's agenda. And I would like to take this opportunity to express our heartfelt appreciation to Dr. Jerome Ramirez for delivering a truly wonderful keynote speech today. So, sir, your willingness to share your expertise with us is highly valued and appreciated. Thank you very much for your time and for your efforts, sir. All right, ladies and gentlemen, now we are actually moving into one of the bits from one of our sponsors. So please behold that message.
Good evening, ladies and gentlemen. We warmly welcome you to the awarding ceremony of Voyage 2023. Throughout the day, you were able to witness the research skills of our fresh graduates and current undergraduates of the Department of Chemical and Process Engineering, University of Peradeniya, through their poster presentations. And this is the time where we reward and recognize the hard work and dedication they have put towards the research studies.
Once again, ladies and gentlemen, this is our backbone, this is our power, and this is our strength throughout organizing all these things that we do in the department. So once again, ladies and gentlemen, thank you very much for your efforts and the dedication that you have towards this. So without further ado, we can now move in to the announcements of the winners, the team that you have been waiting so long.
So, from today morning, we had so much experiences, so much presentations, so much speeches, and so on. And after that, we had the most interesting part of the day. It was the poster presentations. And after a tough selection process, we have received the results. And the third place goes to, with a cash prize of 5,000 rupees and a certificate, goes to Roshan Tharindu Bandara. And I respectfully invite Dr. Anushka Singh to present the certificate and the award.
Can you announce it again?
Yeah, the third place goes to Roshan Tharindu Bandara from E17 batch. Congratulations, Roshan. And the second place of today's poster presentations goes to Bimsara Chandrasekhar to present his certificate and the cash prize of 8,000 rupees. Now I invite Dr. C.S. Halpade on stage. The second place goes to Bimsara Chandrasekhar.
And the first place goes to Rashmi Mohati from E16.
To present the cash prize of 10,000 rupees and the certificate, I invite Professor Parakram Arunarathan, the head of the Department of Chemical and Process Engineering, University of Peradeniya. Alright, ladies and gentlemen, so those are the winners of the poster presentation that we have done today. So we thank our staff members who have joined us on the stage. Thank you very much, Mrs. Madam, once again for joining us on the stage.
Can I take 1 minute? Yeah, sorry. No, I just want to, because I was part of the process of evaluation, I just want to convey you that actually it was a very difficult task to select the best three because I think almost all the presentations were very good, and we have to be very happy about that because they are from the department and also from the industry, and they really appreciate your effort as a student. And then also I should appreciate all these staff members because they were the one who guided them and then committed their time and effort to guide you to this level. So congratulations everyone. So even though we have selected only 3 people, it's not only 3 people, actually almost everyone had done a wonderful job. Congratulations. And then also I would like to pass the message to the junior batches so that you can continue this trend, make sure that we perform best in the faculty. Thank you very much.
Thank you very much for those instructions, sir. It was really a strength. All right, so with that, we would like to extend our warmest congratulations to all the award recipients of the ceremony, and thank you very much, madams, for joining us on the stage. Alright, so while winning is a great accomplishment, it is important to remember that giving your all in everything you do is what truly matters. So kudos to each and every one of the poster facilities that we had today. So with that, we have now reached the final stage of today's agenda. So the day that we have just experienced, the Voyage 2023, was not simply the results of chance, but rather a culmination of countless hours of planning and preparations by many individuals. It's important that we acknowledge and recognize these efforts as they were instrumental in making this event a success. Without further ado, I would like to invite Roshan Kanadu Mandala, the student coordinator of Voyage 2023, to deliver the vote of thanks. Roshan, over to you.
Good afternoon, ladies and gentlemen. After 3 long years, we were able to conduct the symposium of the Department of Chemical and Process Engineering, Voyage, as a physical event. As the student coordinator for this symposium, with the heart filled with humble and pride, I am honored to stand before you today to express my heartfelt thanks to everyone who has made this event possible. First and foremost, I would like to extend my deepest gratitude to Dr. U.I. Disanayaka, the Dean of the Faculty of Engineering, University of Peradeniya, Professor Parakram Karunaratne, Head of the Department of Chemical and Process Engineering, Dr. Nadisha Madasuriya, Chairperson of the Voyage 2023, Professor Nilwala Kortagoda, and Dr. Jerome Ramirez, the keynote speakers of today's Voyage Symposium, beloved staff members of the department and faculty, and other distinguished guests from the industry. Your unwavering support, encouragement, and presence have been instrumental in making this symposium a resounding success. Next, I would like to express my gratitude to all the sponsors of Voyage 2023. In the current financial context of the country, it would have been impossible to conduct an event of this scale without your massive support. Therefore, a big thanks goes to you all. I hope you had wonderful experience at Voyage 2023 and that this partnership between our entities will grow stronger and stronger over the time. There's a special set of people who stays with us through our thick and thins, guiding us and supporting us to get over the toughest of challenges, that is none other than our beloved staff members and our alumni of the Department of Chemical and Process Engineering. A massive thanks goes to you all for all this support and guidance. I would also like to express my sincere appreciation to our judge panel, comprised of 6 lecturers and industrial experts, for taking the time out of their busy schedule to evaluate our students' presentations. Your feedback and insights will be invaluable for our students as they continue to grow and develop their skills. Of course, we cannot forget the contribution of our recent graduates and undergraduates who have worked tirelessly to present their research findings and innovations. While congratulating the winners of the awarding ceremony, I would like to say, no matter whether you got rewarded or not, you all have done a remarkable job. And undoubtedly, you will achieve great things in your respective fields as well in your lives. I would also like to extend my thanks to non-academic staff and technical officers who have worked behind the scenes and ensured that everything runs smoothly. Your hard work and dedication were crucial factors for the success of this symposium. Last but not least, I would like to thank all three batches for their unwavering support and participation in this event. Your enthusiasm and energy have been truly inspiring, and we could not have done this without you. Finally, I want to acknowledge that no event goes without its challenges, and we may have encountered many hiccups along the way. However, I want to express my heartfelt appreciation to everyone for their patience and understanding as we navigate these issues together. It is only through working together we were able to make this event such a success. I hope you enjoy and experience Voyage 2023 to the maximum. And I promise you, Voyage 2024 will be nothing but better. Thank you.
As all good things should come to an end, the time has come for us to conclude the valuable day. We would like to end Voyage 2023 with a quote renowned by the philosopher Karl Marx. There is no royal road to science, and only those who do not dread the fatiguing climb of its steep paths have a chance of gaining its luminous summits.
Indeed, Manisha. And we hope that Voyage 2023 has been a huge push to you in your climb of the steep path of science. See you in a bigger, better Voyage 2024. We are your MCs of the day. I'm Sadhu Tarinda.
And I'm Narishan Rohit.
Thank you for being a wonderful audience. And to conclude the event, let's rise for the national anthem.